I'd like to explain to you why we run into trouble when we try to square both sides of an inequality. It sometimes preserves the inequality, but sometimes it makes the inequality turn not true anymore. So I have 4 examples here with true statements to begin with, and we're going to look at what happens when we square both sides. So if I take the first example, and if I were to square 3, so 3 to the exponent 2, and if I were to square 5, I would end up with a 9 and a 25. Now I started with 2 numbers that were both positive values, so 3 is positive and 5 is positive, and when I squared both sides, my inequality was preserved. Now if you think about this, as long as both of them are positives, you should be fine. It will work that squaring both sides will preserve your inequality. Now let's take a look at the negatives in part B. I have negative 3, which is greater than negative 5. If I were to square both sides, so negative 3 squared would be 9, and if I square negative 5 times negative 5 would be 25. Now in terms of what one is greater, the 25 is now greater than the 9. So in this case, it reversed our inequality. So it looks like the rule might be, as long as your signs are both positive for your numbers, or both sides are positive for your numbers, then you're cool. Your inequality stays the same. If they're both negatives, like in part B, it looks like the rule might be that we need to flip our inequality. That's all fine and dandy, and then if we start adding x's in, and we don't know if x's are positive or negatives, this is all going to go crazy. So let's look at part C now. Here I have negative 3, which is less than 5. If I were to square both sides, one of these is a positive, one's a negative. Squaring both sides, negative 3 squared gives me 9, and then 5 squared gives me 25. I now have that 9 is less than 25. It looks like my inequality is preserved. Now, is that always true? Well, let's see. In part D, I have negative 5 being less than 3. That's true. If I square both sides, I'm going to end up with a 25, and 3 squared is 9. Oh, crap. Look at that. Now our inequality is flipped. So really, I mean, we had a negative and a positive. We had a negative and a positive. It's not like I flipped my negative to one side and my positive to the other. In one case, we ended up having to flip the inequality. In the other case, we didn't. So it's a really challenging thing in terms of squaring both sides of an inequality. You really have to look at it in case-by-case basis. So for the examples that we are doing in class, if we're solving for these types where we would need to square both sides, we're going to look at just solving them graphically. So keep that in mind for now. We'll just stick with the graphical solution for these. You will still be able to solve by square rooting both sides. It's just when you square, things can kind of go awry.